So today I'm going to explain you about the serverless architectures. So serverless architectures have been there for almost a decade now, but still some companies have reluctance to move to serverless architectures. So I'm going to walk you through what are the benefits you can get from a serverless architecture, and then show you a simple architecture diagram of a serverless architecture, and then let's see how we can migrate a server-based architecture to a serverless architecture. So if you move to the benefits, the main benefit of a serverless architecture is that you don't have to take the burden of managing your infrastructure. If you're coming from a site reliability engineering or server administration background, you really know that how much trouble you have to take to manage servers on your own. You need to update the operating systems, you need to update the security patches and certain other third-party tools that are required for your application. You have to manage everything on your own. So this is valuable time and effort that the developers could use to develop business features, to fix issues in their development code that they need to allocate to manage the infrastructure. So if we could get rid of that infrastructure management burden, they can focus totally on the development of their code base, adding extra features to their customers and add value to their product. Then the second advantage is the improved security. So when it goes to serverless architectures, there is no particular server that hackers or any unintended party can access to. Because it's all serverless, there is no IP address or host name they can reach out to do any harm to your system. And also, since all the security updates and operating system updates are handled by your cloud provider, you don't have to take the burden to manage security. So that is how improved security is provided by serverless architectures. Then the third important advantage is the unparalleled scalability. So the serverless systems, they can scale enough horizontally, which is an inherent disadvantage in server-based architectures. If you are familiar, there are two types of scaling: horizontal scaling and vertical scaling. Vertical scaling means adding extra resources like CPU and memory to a single server and giving extra capabilities to that. The disadvantage of vertical scaling is that there is a maximum limit that you can update or upgrade your memory and CPU to. You cannot upgrade beyond that. But in horizontal scaling, you can have several servers handling your load. So horizontal scaling is a good option when it comes to scaling because it doesn't have that limit. But in server-based architectures, due to physical limitation of the servers, you might have issues with the number of network interfaces or other limitations in resources when you use server-based systems. But in the serverless architectures, you don't have those physical limitations because you are just running some code for a small amount of time and then you just delete all the resources. So that way you don't have those physical limitations and you can scale your application so much horizontally and as well vertically and get that benefit of scalability using serverless architectures. Next most important advantage of serverless architectures is the cost optimizations. So if you take a server-based architecture, you might not be using your architecture or your systems, servers, all the time. For instance, you may be using your servers to their peak usage only maybe from 10 AM to 2 PM, where the people are accessing your resources most. But the rest of the time, the resources would be idling, just incurring cost. But in the serverless architectures, the resources spin up only when you need to do a particular transaction or a processing. The rest of the time, it doesn't spin up and it doesn't cost you a single cent. So every time a serverless system is running, it's running only when there is a transaction needs to be done. So you are making sure that every dollar that you spend is used on some processing on your system and not just any idling service. So that is how cost optimization becomes a benefit of serverless architectures. Next, let's move on to a simple diagram. If you are familiar with web architectures, you need to have a front end, back end, and a database. So your end users will be accessing the front end and there will be calls made to your back end using certain routes, and then certain code in your back end will call the database to get certain data, to update certain records in your table. So that is how a simple web application is working. But when it comes to serverless architectures, we will be using something like an S3 bucket and we will be serving that front end content using a content delivery network such as a CloudFront in AWS. So you will be hosting your website in a storage location like an S3 bucket and serving the front end using a CloudFront distribution so your end users can connect to the website. Then when there are calls made to the back end, you will have something like an API gateway that will handle all those calls made by the front end. So the API gateway will have several endpoints to address all those routes, and these endpoints will be calling several other backend services like the step functions or lambdas. So in the AWS, you can call AWS step functions or AWS lambdas to further address those requests from the front end. So in those AWS step functions or lambda functions, you can do the necessary calls to the database to either update the database records or to retrieve certain database records. This is a very simple serverless architecture, and you can make this very complex by incorporating other AWS services like SNS, SQS, but we will move on to those advanced AWS serverless services in the coming lectures. Next, let's see how we can migrate a server-based architecture to a serverless architecture. So the first stage of migration is you should do some assessment and planning. So you should get a proper idea of your current server-based architecture. What are the components or the systems that can benefit from a serverless architecture? Then you need to come up with some technical feasibility, identify the costs, and come up with a rough timeline for this migration. Sometimes you might need to plan for a phased approach to reduce the disruptions to your regular work when you are migrating from the server-based architecture to the serverless architecture. Second step in migrating is the serverless architecture design. You need to understand what are the appropriate serverless services you can do. For instance, you might consider using an API gateway if you have a backend APIs that you want to support. And sometimes based on the requirements of your application, you might have some SNS or SQS service for a queue system you have in your system. And sometimes for the backend processing, you will have either Lambda functions, and if they are super complex processing, you might even go for step functions where you need to do a lot of decision making and a lot of branching in your code. Step functions would be the ideal. So likewise, you have to pick up what is the most appropriate serverless services for your migration. Then you need to design your serverless architecture considering about event-driven triggers, API integrations, and data storage solutions. So in addition to the backend code that will run your application, you might need other supporting services like access controls, what are the additional storages I want, how should I trigger these functions. All those things you need to design at this stage. Now you need to determine what are the serverless functions you need, what should be their input-output parameters, how these functions will be triggered, maybe after a file upload, or when a user writes some records to a database. So that may be the time you want to trigger these serverless functions. So all these things you need to decide at the design stage. And also you need to understand what are the changes you will need for the data flow and integration points. Third step in the migration is the serverless infrastructure setup. So in this step, you are going to provision the required services and resources in your cloud provider. So you might set up your API gateway and AWS step functions, lambdas, and S3 buckets, CloudFront distributions, and even SQS resources. So all those will be created in this stage. Next, you might need to set up the triggers. Sometimes they may be CloudWatch triggers, DynamoDB triggers. For instance, if you want to run a particular Lambda function, when somebody uploads a document or some file to an S3 bucket, you might need to have some S3 event triggers. Or if you want your function to be executed when somebody updates the DynamoDB table, you will have some DynamoDB table triggers. So likewise, you need to have those event triggers also set up, and also the additional services like the S3 storage. If you are going for any additional storage services like EFS, you might need to consider that. So likewise, there are a lot of storage solutions, and even if you think of going for serverless database services, AWS has the Aurora serverless service. You might even consider using that and provisioning resources in that service as well. Then as the final step of the infrastructure setup, you need to have security controls, proper access controls, and proper monitoring mechanisms for the resources that you created. Once you have migrated your server-based architecture to the serverless architecture, it was basically a lift and shift operation. You don't do much optimization for the serverless architecture, and now comes the time where you can consider how you can get the optimum benefits from the serverless architecture, and you try to refactor your application to get the best benefit from the serverless architecture. So you might refactor your existing application to use the cloud serverless services to their best use, and then you might break down your monolithic application into smaller modular components that can be run independently and scale independently. And now also you might need to integrate your API gateway and other backend services and make sure that your event triggers are all running fine. So it's making sure that all the integrations are running fine at this stage. And also you need to validate whether your targets of cost optimization, scalability, and performance, you need to validate whether you are getting those benefits that you intended by moving to the migration. Final step of the refactoring, you might need to consider optimizing your application for performance, cost optimization, and security that you can gain from a serverless architect. Next stage is the testing and validation. So at this stage, you are going to validate your serverless application. So at this stage, you might want to test thoroughly your migrated application, whether it meets the required performance standards, reliability standards, and scalability standards. And you might also need to conduct some end-to-end test whether the data flow is happening and the integration points are working as you expected between various serverless services. Next, you might need to perform some load and stress testing to make sure that your serverless application can handle your expected workloads and traffic. Next stage is the deployment and rollout. So at this stage, you might decide whether you want to take a canary or phase-based approach to gradually deploy components of your serverless application. You might implement a robust monitoring and observability solution to monitor the performance and health of your serverless application. And you will continue to optimize your serverless architecture based on usage patterns, cost, and performance metrics. The last phase is the training and knowledge transfer stage. So in this stage, you might want to educate your development and operations team on the new serverless architecture and its best practices. Also, you might want to document your serverless architecture's design, deployment, and maintenance procedures. You might want to establish a knowledge sharing culture to ensure your team's ongoing proficiency in serverless technologies.